right, folks, welcome to our talk. It's 1:41, so let's get started. I know there's still some people pouring in, but let's get started. Welcome to Databricks Asset Bundles, a unifying tool for deployment on Databricks. Before we start in, let's do a little bit of intro. My name is Peter Nordhuis. I'm a software engineer at Databricks, working on our developer ecosystem team. And what my team is responsible for is the Databricks SDKs. So you can talk to our REST APIs in various languages, our CLI, VS Code extension, Terraform provider, and dabs as well. And that's why I'm gonna talk about that today, together with Connor.
Hello everyone, I'm Connor Brown. Hopefully you can hear me, can't hear myself well. I work for 8451, that means the longitude is Cincinnati, if you're curious. We are owned by the Kroger company, and I'm a cloud engineer responsible for CI/CD on Databricks.
Excellent, thank you very much. And Connor will go into like a customer case study of using dabs. Before we start, I'd like to do a quick show of hands who is not yet familiar with dabs. Okay, perfect, that's great, because otherwise I could skip the next couple of slides. For those of you who are familiar, this may be a little like, bear with us, because you'll know some of these things. But let's dig in. Why do we care? Like, why have we built Databricks Asset Bundles, and why should you care? Now, building reliable software, or teams that build reliable software and services, they typically perform a couple of procedures or processes as part of that software development lifecycle. They typically apply code review. Any changes that are made are reviewed by your team, peers, etc. They have some form of automated testing, small logical blocks of code that can be unit tested, typically a good practice, as well as end-to-end integration tests for your entire system. They apply some form of automated deployment. If I propose a change and I send that out to my peers for review and they agree, and we click like merge or accept, some process should kick off to get that code live. And we don't want any humans in the loop there. That leaves room for error, room for delays, room for mistakes. All of that should be automated. And then lastly, there's some form of environment separation. If I'm collaborating with my team members, I want my own environment in which I can experiment and play around with settings, with code, with libraries, and so on and so forth, and not interfere with my teammates. Right? I want to have my own development sandbox, and only when I'm ready and I think my feature is done, so to speak, I want to send it out and get it reviewed. So, how do we map these principles to developing on Databricks? Right? In terms of code, I'm sure all of you have been in a situation where you have a notebook that you start some analysis in, and it's kind of like exploratory. You try out some stuff, you see some results, and you're kind of happy with it, but you don't want to spend too much time on it, so you just click schedule, and you say, I'm done with it. But then over time, more people add cells, more people add code, and all of a sudden, the job starts to, doesn't run anymore, right? So you have to put some kind of code, some version control on top of that, so you can audit who is making which changes and see what the differences between those changes are. All right, so we're talking about Databricks notebooks, but also libraries, which can be wheels, SQL files, jars, and that sort of thing. Like all the code that you could run inside of a Databricks workspace. The second part that we have to think about is resource configuration. Jobs and code have an interdependency. If my job specifies a couple parameters, that those parameters will be tailored to the code that it's actually running, and vice versa. So if my notebook expects 3 parameters to be set, and my job doesn't set it, it won't work, right? So we want to treat these as an atomic unit. We want to treat the code and the resource configurations as one unit and make changes to that unit atomically. Examples of resources that we might want to configure is pretty much everything that you can create as a non-admin user. So typical examples are like Databricks workflows, Delta Lifetables pipelines, maybe model serving endpoints. There's also Lakehouse monitoring, MLflow models, eventually dashboards. I'll talk about that a little bit later. But all of these you would want to capture a representation of in some form of configuration. And then lastly, there's also this idea of environment separation, right? Because if I'm collaborating with some folks and we're all writing to the same tables in the same schema, we still have interference between one another. And the environment separation can lie at multiple levels. Maybe we're using different workspaces, right? A dev workspace, a staging workspace, a prod workspace. We may have different catalogs that we're working on, right? A sandbox catalog where everyone does whatever they want. But then when we're ready with our change, we're going to do an automated staging deployment, and that's where we have our canonical staging schema, canonical prod schema. And lastly, there's also the identity. Who is doing the deployment? Who is responsible for running those jobs? Because as a user, I may be a part of 5 different teams, or 10 different teams, or 10 different projects. But I don't want my identity to be associated with code for a single project, right? I'd want to use service principles to isolate the reach of that identity within my catalog. So if we break this down further, and this is a very simplistic example, so bear with me, right? So let's say we have a Databricks workspace, and in that Databricks workspace, we have a notebook. And our goal here is to get like a market trends report of sorts. So this notebook is just gonna read some CSV data from the web and turn it into a data frame, do some computations, and show a graph. Very simple. I may want to add a workflow or set up a workflow to run that notebook on a daily basis or at whatever frequency, so that every time it completes, I receive an email or I can go to a page and see that example. So in this case, right, if we go back to the code, the resources, and the environment, what we're dealing with is just a single notebook, just a single workflow, and just a Databricks workspace. And in this case, you might say, well, I don't really care about adding all of this process. This is just too heavy. I don't want to bother. But projects change and goals change. So if the goal changes, say like, I have this market trends report, but actually the data that I'm getting is very valuable for other people that want to do downstream tasks on that data. All of a sudden my project becomes more complicated, and I have to think about the SLAs and the guarantees that I give for my users of that table, right? And the code will change, it will grow, right? I no longer have a single notebook, I now have a notebook, I have some source files for the DLT pipeline, maybe that's some SQL, maybe that's some Python. It could be a bit of both. I no longer only have a Databricks workflow, I now have a Databricks workflow and a Delta Live Tables pipeline. And I'm working against the Databricks workspace and a Unity catalog schema, and that can be like a dev, staging, prod schema, and so forth. So this is just to illustrate that even though you may start with a very simple example or composition of code and resources, they tend to sometimes grow. And then it becomes harder to manage. So lastly, if we're working on this system in a collaborative situation or collaborative scenario, like we have a team, the team is responsible for this market analysis project, then if I make a change, what I would want to do is apply standard software development lifecycle kind of practices with respect to version control. I check out a feature branch and I work on whatever I'm working on, but since this is not just local code, where I have a local copy of my code, I can locally run some unit tests, it's actually like a Databricks workflow, right? And that's very important. The configuration of that workflow is an integral part of that project. So what I want to do is do a deployment of my feature branch, of my local code that I have, and get a development copy. This is my own job, my own Delta Live Tables pipeline, and it just writes to a dev catalog. When I'm happy with the changes that I made, and I think I'm ready to share this with my peers to get a second pair of eyes on this change, I'll make a pull request to a main branch. At that point, we'll do another deployment where we can run an end-to-end test. And perhaps at that point, we're not only running unit tests, but maybe also a black box integration test, right? Where we say, you know what, let's run this market trend analysis, but only apply it to maybe last year's data instead of the last 100 years of data, right? So it's not as computationally intensive, but it still gets us the signal of, whether or not the changes work. And then lastly, if we're happy with all of that, we get a green signal, we want to release this or release this to a release branch and do the accompanying deployment to production. And each one of these deployments will be independent and will be slightly parameterized. So let's take a short look at the properties so far, right? Talking through this, this is all leading up to Databricks Asset Bundles, of course, but let's first identify the properties that we're actually looking for. So the first one is that we want to have a single source of truth for our code and our resource configuration. We said that this is codependent, right? We want to have the code and the resource configurations in sync. So in order to do that, we're going to stick that in the same version control repository, Git repository. The second property is that we don't want to learn anything new. We just want to have some kind of easy to read format. You can look at it and in a single glance understand what's going on. So it shouldn't add too much like cognitive overhead for our users. We want to be able to specialize these resources based on the target environment. Right? Perhaps in my development deployment, I would want to use a single node cluster because the amount of data that I'm working with while I'm testing is very small. And I don't want to blow up costs, right? I don't want to have a team with 10 members and each one spinning up 32 node clusters, right? That would be silly. So we want to have small clusters in dev. Perhaps in staging, we're working on a little bit more data. So we say you get a 4-node cluster and then prod, you'll run with a full-sized, I don't know, like larger cluster. And those types of specializations we want to capture in this configuration. We'd want to have deployment isolation, right? If I'm collaborating with someone on my team, I want to make sure that I have my own copy that I can iterate on, and my team, my colleague also has their own copy, and we shouldn't clobber each other or shouldn't interfere with one another. And then lastly, we'd want to easily apply automated deployment and automated processes on top of this. So enter Databricks Asset Bundles. So far, the folks who have been using Databricks Asset Bundles, you maybe recognize these properties, but I hope it's also clear for the folks who are not familiar with Databricks Asset Bundles the reasoning why we started to do this. So what is a Databricks Asset Bundle? It is a declarative configuration format that allows you to capture resource configuration, workspace configuration, and environment configuration in a single place, and you can co-locate that with the source code of your data project. You can interact with this Databricks Asset Bundle through the Databricks CLI. The Databricks CLI is doesn't only contain bundle commands, but there's a bundle subcommand that lets you do all of these operations. You can validate the bundle configuration while you're iterating on it. You can deploy the bundle configuration to your workspace of choice, and you can interact with the resources that it defines. So if you include a definition of a workflow as part of that bundle configuration, you can use the CLI to actually kick off runs and parameterize it and so on and so forth. And yeah, where do we execute it? It's client side. So we don't care where you run the CLI. You can run it locally on your laptop when you're doing development. You can run it on your CI/CD runners, right? GitHub Actions, Azure DevOps, what have you. There's a wide variety of systems out there. And in the near future, you'll also be able to run these commands in the Databricks web terminal. So if you're in the UI. So let's take a little bit closer look at the contents of this Databricks.yaml file. We start with the bundle definition. That's all the way at the top. And everything has to have a name. So bundle also has to have a name. So we have a bundle block with a name property, uneventful. Then we have an include block. If you have a single job, it might be okay to just stick that in the Databricks.yaml file and you don't bother with includes. You say, this is like my whole file. If you have 10 jobs, it becomes a little bit unwieldy, right? Because now you're looking at 500 lines of YAML code, and I haven't met anyone who enjoys doing that. So you want to kind of decouple that and say, you know what, I'm gonna split that up, the configuration up in multiple files. That's what the include block is for. And then you can combine all of those files together in a single configuration. And the third one is the workspace authentication, where you can set up the workspace host to talk to. And then we have a resources block where we can define the job that we're talking about. And in this case, we said, hey, we're doing some market analysis. So we have a job named, or with the identifier market analysis refresh, with a single task that runs a notebook. And yeah, that's kind of it, right? Straight to the point. One more salient point here is that you see that the notebook path here has a relative path. And that relative path means that path is resolved relative to the location of that Databricks.yaml. That means that you can take that whole directory containing that Databricks asset bundle and just move it around, and it'll remain self-consistent. The second bit is really about these like environments, environment isolation, right? So we have deployment targets. In this case, you'll see 2, dev and prod. You can have 0, and we'll have like a default target that you don't have to worry about. You can have 100. It doesn't really matter, but I don't expect it to be too many. But these targets can capture the overrides, if you will, of the resources, of the workspace, kind of customize the bundle to a deployment target. You see here that the workspaces are overridden on a per target basis, allowing you to use different workspaces for different targets. Perhaps that's a setup that you have. It also allows you to override the job cluster here to have 32 workers instead of 1 or more. And this piece of configuration is merged into the base configuration to get the final configuration. CLI commands, as I mentioned before, you can validate the bundle configuration. You can deploy. What happens on the deployment is we synchronize all the files that are in that directory of where the bundle is located, and we synchronize them into the workspace, and we deploy each one of the resources that are defined in the bundle configuration. So that's kind of the atomicity, if you will, of a bundle. You get that at deployment time, and you can run resources to interact with them. The snippet I show here is one that highlights the type of thing you could see at validation time. When we started out working with bundles, we didn't have all of this, and we ran into customers expecting some field to do something, didn't work, or typos, or YAML misindentation, and all of that. That's luckily a thing of the past, because if you make any typos, you'll see that here with a pointer on where to correct them. Lastly, I want to talk a little bit about bundle state, because what is a bundle deployment? It's kind of an ominous thing, because it's not just a bunch of files, it's also resources. So a bundle deployment is really a path in the workspace file system where the bundle commands store both the files that are part of the bundle as well as some state files, right? That state that we maintain in order to know which jobs have been deployed or which resources have been deployed as part of that bundle. That allows us to know if that path doesn't exist, it's a new bundle deployment, right? And we just start from scratch, we create everything that's defined in that bundle. But if it already exists, then perhaps we need to update jobs that have been deployed previously. If there's a job that we previously deployed but no longer mentioned in our configuration, we may need to delete it. All right, so it takes care of all of the life cycle of the resources that are part of that bundle. By default, the path is home_.bundle, and then we interpolate the bundle name and the bundle target, which means that every user, every bundle name, and every bundle target gets them their independent deployment. If you need additional dimensions, right, perhaps a pull request identifier, right, if you do multiple validation deployments or what have you, or per feature branch, then you could override these defaults and customize this further along. So, to get started with bundles, you can run Databricks bundle init, and I'll show you that in a second. To get started with one of the built-in templates. It is also possible to build templates yourself for bundles. So if you're on a data engineering or a data platform team in your company, you could say, hey, I want to be prescriptive on how people set up their data projects, and you author a bundle template, and that's the way to get started. If you will, in a company-compliant way. But there's a couple built-in ones that allow you to get started very, very easily. It's also possible to start from existing code and resources using the generate and bind commands. The generate command will take an existing job in the workspace and turn it into equivalent YAML locally, as well as import all the notebooks that are referenced in that job and copy them into your local tree. So if you have existing stuff you want to start managing through dabs, it's possible to do that through the generate command, and then the bind command allows you to attach the identity of that job, that literal job with that specific ID, to your bundle deployment. We split this up into 2 commands because sometimes you'd want to generate the YAML, but create a copy of that job instead of overriding it in the future. So what I'm going to do next is show you a little bit of what this looks like, and we don't have like all the time in the world, so this is going to be pretty short. But is this big enough? Yeah. Okay, excellent. So the Databricks CLI, here I have the latest version installed. There's the bundle subcommand, and you see there's a whole bunch of commands, but I'm just going to focus on the init command because I want to start a new project. And there's a couple built-in templates, one for starting out with Python, starting out with SQL, DBT. There's also MLOps stacks that some of you may have heard of, which is an opinionated way to start with ML training and productionization. But I'll start with the default template, the default Python template. If I choose it, I'll be prompted for a couple questions. So we'll pick a name. Do we want to include a notebook? Sure. Delta Live table pipeline? Sure. Python package? Sure. Do everything. Great. So now what it did is generate a directory, right? My project that we'll just go and take a look at and open it in VS Code. So there we are. So I'm going to hide this for a second and open up this one. And we see there's a bunch of files here, right? We start with the Databricks.yaml file, and this will look familiar. If we go back to the slides we were looking at previously, we have a bundle and a stanza here with a name. We have an include block. We have two targets here, a dev target and a prod target. And in this case, they both define a workspace, but it's the same workspace. That's just for starters. Of course, if you have multiple workspaces, you could easily replace this and just use this as a starting point. That's also how we intend it to be used. And then if we go into the resources block, we see a job and a pipeline. These could be co-located in the same file, but just for convention, we say we put one resource in one file to keep it keep it tight. We see the resources block, jobs, this logical identifier for the job, and then all of these properties. These properties are a one-to-one mapping with the REST API payloads for these resources. So if you're ever in doubt if some obscure feature is supported or not, you can go into the API docs and figure it out. That's one way. Another way is actually to use auto-completion here, because if you've set up the VS Code extension, then it'll automatically load the schema of this full configuration, and it allows you to just kind of auto-complete your way through configuration here. So if we want to set up some tags, then great, we can set up some tags. I'm not going to do that right now, but I am going to invent a new email notification, right? So on foo, we want to also email foo@bar.com. And this is just to kind of highlight what happens if we do this. We'd see, oh, hey, there's an unknown field. So we'll click into this guy and then immediately see that it's bad. Well, we could have seen it here because there's a schema validation at this level as well, but oh well. Another feature that I kind of glossed over is that all of these fields also have documentation associated with them, which originates from the API documentation as well, which can be very convenient. And the last thing to note here is that we see this one here, where we want to refresh a pipeline, which is a different resource in the same bundle as part of this job, and we interpolate and kind of late bind the ID at deployment time. We don't know what that ID is going to be when we haven't deployed it yet. So we can refer to it here, and we'll make sure to deploy the pipeline first, interpolate the variable, and then deploy the rest. So the last thing I'll show you is a quick deployment. And a deployment. So we're now uploading all these files into this workspace path. We're capturing some state, and we have deployed it. If I now type Databricks bundle run, I can do run my project job, for example, and it will kick off the corresponding job, which if I open it, I hope it works. Oh, it does. Then you'll see here that this job is namespaced, right? It's if multiple people on my team are deploying these jobs, this allows me to tell them apart. And we see this banner here connected to Databricks Asset Bundles to say that, that's where it comes from. It doesn't make sense to make changes to that job here because any change you make here will be clobbered by the subsequent deploy anyway. And I'm not going to wait around for this to complete. This is just the bare bones, but you've seen the commands. These are commands you can all run yourself as well and then start exploring, so I'm not going to do that for you here. There's a bunch more topics that I haven't covered, for which I will refer to the documentation, like ownership, complex variables, how to author dApps with Python, and working with dashboards. Those are some things are in flight, some things are going on, and some things are already possible. But I'm going to stop there and ask Connor to talk a little bit about 8451.
Absolutely. Thank you, Peter. I'm going to steal the clicker here. So a little bit about 8451, just to give you a sense of who we are and how we've been using DABs. So we have several hundred Databricks users at the company. We have several different workspaces that we've created to break up environments, like Peter mentioned earlier, such as dev, stage, and prod. And we are a retail data science company that serves exclusively the Kroger company. About 1,500 people, say roughly half of them have some amount of experience with Databricks. So a little bit about DABs at 8451. So about a year ago, we started rolling out DABs to machine learning, data engineering, and ad hoc data science use cases. But before we did that, we wrote an internal tool called Cyclops. So Cyclops is a tool that was completely built in-house to try to cover some of the same things that DABs now does. And it was covering things like CI/CD of Databricks assets, and it would also help promote code across dev, stage, and prod, like I mentioned. So this established Cyclops user base that we already had at the company, at the time around 100 users, was key to our success in rolling out DABs. So a couple quick facts about Cyclops. So Cyclops, I'm going to use it a little interchangeably to describe both a platform engineering team that we have at 8451 supporting Databricks, as well as the name of a product that team maintains. And it's used to provision landing zones in Databricks, meaning you have an idea that you'd like to take to Databricks to try out, whether it be ML related, data engineering related, or ad hoc data science. You can get started in Databricks in just under 10 minutes by starting with our service portal, getting a GitHub repo from the service portal, as well as some templated code that you can begin deploying to Databricks. You can already sort of get a picture here of why DABs might be a natural fit for us. So we've now, as of today, had Cyclops used just over 200 times, and everyone since about a year ago has been deployed with DABs. So we have three primary components to Cyclops. The first I already mentioned, which is the service portal. And I'm not going to go in too much of a demo here because I do want to make sure we save time for questions. And the service portal is just a very simple form that we have users fill out. We ask things like, what is the name of your project? What type of data might you need access to? As well as some GitHub and metadata related information, such as, since we're creating a repo for you, who is going to approve pull requests in that repo, since we require that you do have protected default branches. The service portal, after it gets that information from the user, then passes the information to our automation engine, which is actually just Terraform. And Terraform runs with the variable it's received from the service portal to create around 90 different resources across Azure, Databricks, and GitHub. So finally, another component that we manage of Cyclops is a GitHub Actions reusable workflow. Do we have any GitHub Actions users? Okay, quite a few. So you might know what reusable workflows are. If you don't, what they are is basically just a CI/CD workflow that we can maintain centrally, and our customers can use that as a template in their own repository that can change over time. So this has been one key to us being very successful with deploying to Databricks, is having that reusable workflow that the platform engineering team can make updates to over time. For example, when DABs first came out and we decided we'd like to give it a shot, we were able to add the bundle CLI commands to that reusable workflow with a feature toggle. Say, hey, if you're interested in trying out bundles at 8451, all you need to do is this little feature toggle, and now your CI/CD pipeline will start using the bundle commands. So what does the user get? Again, it's about 90 different resources. I have a few highlights here. Starting on the left, you get that GitHub repo. You also get the actions workflow, as well as some environment variables where we store things like a Databricks pat, some other information required for connecting to Databricks, such as the URL of the workspace. And in Databricks, we basically set up a lot of RBAC and a directory for you to begin deploying into. Finally, in Azure, we create that service principal, a key vault for maintaining a secret scope, as well as some intra groups for granting access to the directory. So where does DABs actually fit into Cyclops, everything I was just talking about? So before DABs came along, We had quite the backlog. We thought it was going to take us probably a year and a half, 2 years to get through the backlog. All the feature requests we had coming in, very small team. At the time, there was only about 4 of us working on Cyclops, despite the number of users we had. So one of the biggest items on our backlog that we were trying to tackle at the time, Cyclops could only deploy 1 job at a time. We would stamp out these GitHub repos with a job spec in JSON, say, modify that JSON file, rerun the CI/CD workflow to deploy that 1 job. And it was actually pretty complicated for us to come up with a way to loop in GitHub Actions because that's not supported out of the box to deploy multiple jobs, right? But then came dabs. Since dabs has a YAML format that we can work with, and you can just add additional jobs to that 1 YAML file or split it out and use include statements. Day 1, we now had support for multiple jobs, and it solved a pretty good portion of our backlog. We also didn't yet have support for models, Delta Live tables, or experiment resources. And we were able to add that as well on day 1 as soon as we began using dabs. So I wanted to highlight a couple bonus features that Peter hadn't already talked about that we realized after turning on dabs in our workflow. So on the left, I have highlighted this thing called the lookup feature. If you're using more than 1 workspace in your CI/CD pipeline, then there's going to be some mutating values between those workspaces, right? Like what Peter mentioned with targets. One that we had right away were instance pools. Anybody use instance pools in Databricks? A few hands. So those instance pool IDs change per environment, right? Even if maybe they're actually the same underlying compute. So one thing that we got out of dabs was the lookup feature, where we were able to add just a name of an instance pool, which does not change per environment at 8451. And when the bundle deploy is executed, it looks up the ID of that instance pool for usage and later job specs or anything else it might need to use an instance pool. So this was a huge lift on the user experience because before we had maybe 20 different instance pools to pick from across 3 to 4 different workspaces a team might be deploying to. So you can imagine what it was like trying to communicate those IDs to users, having them store them as environment variables or hard coding them in the GitHub repo. This is a huge lift in the user experience. We no longer had to do any of that. We just shared, these are the names of the instance pools. They're the same across all workspaces. Just pick the one that you need to use. As long as your cluster policy allows it, you're good to go. The second, on the right side, this is substitutions. So in the default parameter there, under the train and register model, I'm using a substitution to look up the name of an MLflow experiment that I've created with the same dab. So what this has really done for us is really increased the reusability of our repos. So let's say we have a team that they have a really nice MLOps workflow, and we'd like to encourage that team, hey, would you mind sharing that and publishing that with the rest of the company so they can take advantage? Well, they don't have to hard code their experiment IDs in that bundle, right? They can keep hard-coded IDs out of the bundle, just use these substitutions there and have an experiment defined separately towards the top of that bundle. And when the experiment is created, that experiment's ID is then passed as a parameter to this job, and the job would then ultimately use that experiment to train the model. So I'm actually going to gloss over this section really quick because we are running low on time, but this is just a brief example of how we've used dabs in an actual workflow. So you can see in GitHub Actions, we make a commit, or we can manually trigger our workflow, and a bundle deploy is then kicked off. And this is I should have mentioned, this is an MLOps workflow, by the way. And the bundle deploy is creating those jobs for both training and model deployment or promotion in Databricks. Model training is kicked off via the bundle run command in GitHub Actions, which is a blocking action. And if something goes wrong with the training job in Databricks, we'll get immediate feedback in Actions. And the reason I did want to spend a little bit of time here is you can imagine that having that immediate feedback in GitHub Actions is very helpful for blocking pull requests, so that your team has a standard of, if your model is not performing better in the newly trained model than it was before, you can't merge that pull request to mate. So that's the type of workflow that's been enabled for us by bundles. So a couple key takeaways on how we were able to roll out dabs so quickly to our community at 8451. First is that platform engineering team I mentioned. We felt that it was key to have a platform engineering team that was diverse across CI/CD disciplines, across Databricks. We had ML engineers, we had data scientists that were all involved. A community of practice was hugely helpful. So over time, as we were making changes to Cyclops, we were able to introduce these new bundle changes to the community of practice, get feedback, and then make changes as needed. And finally, example workflows or dog food. As we were making changes to our GitHub Actions reusable workflow especially, we forced ourselves to come up with a product, even though it wasn't actually used by the company, just to test our own changes and see if we liked them.
All right. Thank you very much, Connor.
Absolutely.
So I think wrapping up, if you want to try out this stuff yourself or reproduce the commands, learn more about Databricks Asset Bundles, go check out these links. The QR codes link to the links in front of them, so just for convenience. And then,
next slide.
Whoop. There have been other sessions. These are all past sessions. But if you want to learn more and see more demos and more details about Cyclops and more about like using IDEs with Databricks and dabs with IDEs and like all of those permutations, make sure to check out these talks when everything gets posted online. And with that, I think we're there. So thank you very much for your attention.